Okay, welcome back from completing the storage policy lab for traditional storage. Let's see what it's like to do a policy against vSAN and see what the difference is. That's what you're going to do in the next lab. But hold on, let's talk about vSAN. We're going to go through an overview of vSAN briefly, but mostly about how storage policies are effective in vSAN. So we'll take a look at the key components of the vSAN architecture just to get through the basics and also create some vSAN storage policies. That's one of the main goals here, to go through that, right? Just to be familiar with what are the different kinds of policies. We just saw with the traditional storage, you were able to view the compliance of a VM as that relates to where the VM has been placed with their policy. Here in vSAN, that's different. Now vSAN will actually enforce the policy. So what's vSAN, right? vSAN is a software-defined storage solution where that all the ESX servers in a cluster, you're going to have an HA and a DRS cluster. In addition to that, you enable vSAN, leveraging local storage or direct attached storage across the hosts in that cluster, of which you can have anywhere from 3 hosts up to 64 hosts in a cluster. It's a little different than HA-DRS. HA-DRS, you can have 2 hosts in a cluster. This requires 3 hosts in a cluster, but you still max at 64 hosts. And then the disks across the hosts in the cluster work together to aggregate all of their storage capacity into one big logical vSAN data store. So it is a single data store here. We're not going and creating multiple data stores in the same vSAN cluster. You build a single vSAN cluster where all the hosts, or some of the hosts, all contribute storage. Right? Some of them can, right? Generally, the best practice is to actually populate every host with disks, so every host can participate in that cluster, but it's actually not required. So as you see in our picture, though, not all the disks are the same, though. The way how vSAN operates is that you actually need to have an environment that basically mimics SAN-like capabilities and features and performance, but doing all of this without an actual SAN. This is a virtual SAN, essentially, right? By using direct attached disks. So how do we gain the performance of typical SAN capabilities? We need a set of disks that have high performance, high endurance, dedicated for caching purposes. So you'll see that every host that's got disks contributing to the vSAN cluster are going to be broken up into one or at least one cache specified disk, and then potentially multiple disks matched or marked as capacity disks. So you have different kinds of disks performing different functions. Cache disks are basically being primarily a write cache. They can also be a recache depending on how you set up your vSAN. And then you have the capacity disks, which are basically holding the persistent data. Now, again, those cache disks need to be of the highest performing and highest endurance disks that you can afford. They're going to be flash-based, of course. The capacity disks, on the other hand, they could be SSDs, they could be magnetic drives. That's an option that customers get to choose. Do they want to have an all-flash solution where everything is a flash drive, the cache tier and the capacity tier, or are you going to go with a hybrid model where the cache tier, which is always going to be SSDs, but the capacity tier in that case is magnetic? Now, whatever solution you go with, it has to be an entire uniform configuration, right? So all the hosts are all flash or all the hosts are hybrid. But that cache disk is always of the highest endurance, highest performing disk that you can afford, because basically all of the majority of the IOs are going to hit that cache disk, and then as the data becomes less active, it'll become destaged to the capacity area. So your total vSAN data store size is basically aggregating all of the capacity disks into one big logical data store. So as we just mentioned, you have your 2 options: all flash, where you have the cache and the capacity disks are all flash. We're not telling you to go out buy the exact same disk for the cache tier and the capacity tier. Ideally, what you do is you get probably a smaller but faster and higher endurance disk for the caching purposes, and the larger capacity but maybe not as fast and not as high endurance capable capacity SSD. So you don't have to necessarily buy the same SSDs. This just makes the way in which the vSAN operates going to perform far faster because of the high-speed caching tier that we've got. Hybrid, on the other hand, you have to have the cache tier always as an SSD, but now the capacity disks are magnetic drives. The all-flash solution, by the way, since that will generally cost a bit more because you are buying flash storage throughout the entire cluster, this offers some space-saving capabilities to help alleviate some of the cost of the extra cost of the disks, we offer compression and data duplication in the vSAN cluster to really reduce how much actual utilization on the disks, and also the way how we implement RAID. Now, we haven't really mentioned RAID, but vSAN itself is not doing disk level RAID, right? You have, again, all of the capacity disks are all one big aggregate logical vSAN data store, right? At the native disk level. There's no RAID there, right? We're not grouping all the capacity disks in some kind of RAID operation here. In fact, the ESX servers themselves who have the disks, they may have the disk controllers are RAID controllers. You want to make sure that's turned off. You want to make sure that the disks are either, or I should say, the controllers are in pass-through mode, or if the controllers don't have that option, they just need to be made sure that the capacity disks are all in a RAID 0 configuration, because we don't want to have any disk RAID. We're doing RAID in vSAN at the VM level. That's actually part of the policies. So you can actually have VMs. Some VMs can be set up as a RAID 1 mirror. Some VMs may be set with RAID 0. Other VMs might be RAID 5. You get to choose how each VM is to be implemented in their own levels of redundancy, which gives you that granularity and puts the VMs basically as a first-class citizen in your storage environment. And that's really what makes a difference with this type of environment. The software-defined storage typically means the VMs have first-class citizenship in your storage. VMFS and NFS, on the other hand, that's traditional storage. The VMs aren't the first-class citizens. Imagine you have to first create a LUN, format it with VMFS. That LUN got created with RAID, probably, based on the general requirements you needed for an environment, but that's not giving the VMs first-class citizenship. Your VMs are basically just customers to this LUN. The LUN was the first-class citizen in this case, right? Somebody had to build the LUN based on some general requirements, and the VMs are basically going to get fit in there in somehow. With vSAN, each VM can be individually policy configured to give the VMs exactly what policy their workloads require them to have. So the way how these disk groups are actually created, right? When you have the disks populated in the ESX servers, they're formulated into this concept called a disk group. Basically, a disk group consists of one cache disk and up to 7 capacity disks. And so you have a group of 8 disks in a disk group, that cache and then the 7 capacity. And this basically forms to the way how internal controllers tend to be configured. Most controllers have 8 ports, so this makes up the typical arrangement for a disk group. And if your server has multiple disk controllers, you can actually have multiple disk groups attached to a host. In fact, you can have up to 5 disk groups per host, creating a grand total of 40 total disks that could be implemented inside each and every one of your ESX servers. Now, they don't actually have to be internal drives sitting in drive trays. They just need to be direct attached. So if you happen to have a JBOD, an enclosure just filled with disks, and just have a SCSI direct connection into the host, well, you can do that. And you can do that with each and every host to provide high capacity and high density in disks inside your ESX servers. So creating that vSAN cluster basically shows each host and how many disk groups are inside each host. We can see in our example here, our host number 1 happens to have a disk group, and then we can see which disks are in that disk group. We see that 1 has been marked as a cache disk, and 2 have been marked as being capacity. They are all flash though, but that's a pretty standard setting for an all flash environment. So that makes up the introduction to vSAN. Let's take a look after the break at how we actually implement policies in the vSAN environment. So stay tuned. We'll see you on the next section.